interesting conversation today. I've got Jeff Draa, who's the CEO of Grolltex, and he's in California, and I'm in Yorkshire in England. Good morning, Jeff. How are you?
Good morning, Adrian. Good afternoon to you, I guess it is.
It is, yeah.
Things are well here in San Diego, and hope you are too.
Yeah, very nice. Yes, things are really good here. Spring is springing, and things are getting better. Now, the viewers will know that I hold this sample up quite a lot in my presentations. This is CVD Graphene, monolayer graphene, quite a sophisticated product. And there's a one atomic layer of graphene on that. And the reason I know that is because Jeff's company made this, and Jeff sent this over to me, and I have the certificate of analysis here to prove it. So, Jeff, this sample has had a lot of miles. I've shown it to a lot of people. Could you explain to us how you go about making this stuff and what your process does?
Certainly, happy to do that. And you know, we think of it the same way here. Arguably, you're holding in your hand the most advanced building material humans have ever produced. I think maybe scientists could argue there are some other things more sophisticated, but from a practical standpoint, you're holding something that cost us much less than $100 to produce, and it could be used to make biosensing devices, semiconductor chips, and many of them. So yeah. So the way that we make this material, to answer your question, is a process called CVD. It stands for chemical vapor deposition. This is a very well-known process. It's been around for decades. The computer chip guys have been using it for a long time. It's used in many other industries as well. And chemical vapor deposition is actually very simple. We take a chamber, and we have several of them here at our factory. And in this chamber, in this case, to grow what we want to grow, we use copper foil, as you saw Adrian hold up there, as the growth substrate. So in this chamber, we insert some copper foil, and then we seal up the chamber. And then we create conditions in that chamber by pumping it down to vacuum, the opposite of pressure, of course. We kick up the heat in the chamber to about 1,000 degrees centigrade. And then we insert a combination of gases. Principally, we use a very well-known gas, methane, to do what we want in this chamber. And methane is CH4. And what we're doing is we are breaking apart the carbon and the hydrogen in that chamber. And what happens is the hydrogen and carbon separate. The hydrogen cooks off into the atmosphere as water vapor. The carbon settles down on that copper foil, and it assumes this lattice structure that looks like chicken wire. And so when we're all done, we open up the chamber, we pull out that copper foil, and on the top of the copper, as Adrian mentioned, is this monolayer of carbon atoms that have assembled themselves in a structure. And it's a very useful film for several reasons. Principally, we use it for electrical conductivity. So it's very conductive, more conductive than the copper that it sits on. So this film can be used for many advanced applications. So that's, in a nutshell, that's how we make it, via CVD, or chemical vapor deposition.
Once you've got the graphene covering the surface of the copper foil, that's fine, but you go one step further, don't you? You've developed quite a clever transfer process to get the graphene off without damaging it. And then you can use it in other applications, which we'll talk about in a minute. So how do you do the magic of getting the graphene off without damage?
So you're actually describing the reason that we started the company at all. Grolltex is short for Graphene Rolling Technologies. And the process I've described so far, this creating graphene via CVD, we did not invent that. That was created by some very smart people, and depending on who you want to listen to, there was a team in Korea and a team in Texas that did it at about the same time in 2010. One of the key things that's going on there is you can make your graphene on copper, and when you're done, you're holding, as Adrian was, you're holding in your hand this graphene on copper foil. And now the pickle is, well, how do I get it off of here and onto the surface that I care about? Maybe it's a silicon wafer because you're going to make an advanced device or some other receiving substrate. But the point is, you want to get that film, that carbon film, off of the copper. And key is not destroying the copper, because prior to Grolltex, the way that people were removing graphene from copper was acid etching this copper. And acid etching copper creates a really toxic effluent. It's really one of the nastiest things. And it's very expensive because you're destroying hyper pure copper. Copper is already expensive, but the type of copper that we need to grow what we need to grow is very, very expensive copper. So acid etching copper was not scalable at all in any sense. Grolltex, we came up with a way to remove graphene from copper and reuse the copper. And there are a few ways we can do it. Our principal patented way is called MAE, or metal-assisted exfoliation. And very briefly, what we do is we put another layer of metal on top of this graphene, which is very counterintuitive, by the way, because most people get their graphene on copper and they think, well, metal bad, I want to get rid of the metal, I want the graphene. But what we do instead is we double down, we put more metal on top of it. And the reason we do that is this new metal layer on top of the graphene has about a 7 to 10x adhesion strength to the graphene as compared to the copper underneath. So in effect, we peel this graphene off the copper, then the copper goes back into the factory to reuse again. Now we have metallized graphene, and we actually use this new metal layer. We can pattern this and make devices out of it. So now we've got graphene with patterned metal that can be made into OLEDs or panels for displays, or in our case, sensors, biosensors. So many ways to use this patterned graphene.
Clever. So you've got the graphene on the copper foil, and then you're introducing something which is stickier than the copper, and then that effectively does the transfer. And
Precisely.
because you've got a big layer of metal foil going on, then the force is even and it doesn't damage the graphene in the separation.
Precisely right. Now, I don't want to trivialize this. It's not, it's not an easy thing to do. And in fact, when I saw my partner, Dr. Zaretsky, in his research lab at UCSD and what he was working on, I thought, well, this is really important. This has to be brought out to industry. So we formed up a company, and voila, Grolltex, graphene rolling technologies.
Yeah, and you're becoming successful as well. So very best wishes, Jeff. Thank you very much for your time.
Thank you for having me, Adrian. It's a pleasure talking to you, as always.